Welcome to Engineering Update, brought to you by Mouser Electronics, the electronic components distributor with the widest selection of the newest products. I'm Jeff Ranke, Editorial Director of ECN, and this week's headlines: easy LEDs, portable large-scale 3D printing, smart home robots, a printable bionic ear, and charging phones with pedal power.
The SiVa Atom is a mountable device that uses manual energy produced through bike pedaling to charge a smartphone. The removable 1300 milliamp per hour battery can either be charged separately or connected to your device for a more direct charge. The SiVa Atom functions at a 500 milliamp rate and works through a small gear, which is triggered by the spinning of the rear bicycle wheel. The current produced by rotation passes through internal electronics, where it is converted to energy.
The lightweight SiVa Atom weighs just 10.5 ounces and stands 7.5 inches tall. A recently launched Kickstarter project has already far surpassed its funding goal. This just cements one of my theories. Forget the wind farms. Let's just hook the local gym up to the grid for the week after New Year's, when resolution optimism is at its height, and the week before spring break, when swimming suit paranoia is peaking. Energy shortage and rising obesity-related healthcare costs solved.
Another recent project to light up Kickstarter are the Klauf Light Bars. The portable LED strips come in 6 and 12-inch lengths and can be arranged and connected in reaching up to 15 feet in total length. Their versatility allows the user to install LED strips in hard-to-reach places, around corners, and just about anywhere you can think of.
The light bars can be plugged directly into a socket or mounted for permanent placement. The lights come fully integrated to avoid hassles with external transformers or DC converters. Also, unlike other LEDs, the light bars come in 2700K color via a phosphor diffuser that absorbs the high output blue light emitted by the standard LED. The light bars currently emit 210 lumens with an efficacy of about 50 watts. However, according to this product's designers, this is just the beginning in terms of power and brightness. I guess you could say.
The future's so bright, I gotta wear shades.
A new 3D scanner called the GhostScan from Creaform is 10 times faster than other similar devices and is completely portable. The GhostScan 3D resembles a cordless handheld drill, which is ringed with white LEDs. The user simply points the scanner and pulls the trigger, while sweeping the device over the surface of the object to be scanned.
The GhostScan 3D operates by shooting patterns of light onto the object's surface that is then bounced back and captured by the camera. The coded light patterns are actually QR codes, which the device then uses to create an accurate, true-to-life replica of the scanned item. The software is parsed by internal software, which produces an accuracy up to 0.1 millimeters, or 100 microns. Scanned images can then be produced by any standard 3D printer.
There is no denying that the world's elderly population is steadily growing, and in the world of advanced robotics, new technologies are striving to keep independent living an option for as long as possible. Honda has recently announced that it is teaming up with Japan's Sekisui to design model households using smart technologies.
So far, the robotics program has created humanoid robots in a personal mobility vehicle. The walking assist device incorporates a body weight support system, which is ultimately a lower body exoskeleton that reduces the stress on joints and muscles. The other half of the research team is the Sekisui house, which is working to develop a power system focused on creating completely synced relationships between the smart home and electric cars. Alright, wait a minute. Automated house, advanced robotics, body weight support system. Melissa, is there something you're not telling us?
An exciting new project developed by scientists at Princeton University has succeeded in producing a functional super ear by using off-the-shelf printing tools and electrical components. Scientists have merged the electronics with human tissue by using 3D printers to combine a small coiled antenna with cartilage. The ear can reportedly detect radio frequencies far beyond the normal human range.
The ear holds a coiled antenna inside the cartilage structure with 2 wires that lead from the base to the cochlea, which is then connected to electrodes. The ear can be used to either enhance or fully restore a patient's hearing, as the electrical signals produced by the ear are connected to a patient's nerve endings, similar to a hearing aid. The current system receives radio waves, but the team plans to incorporate other materials, such as pressure-sensitive electronic sensors, to enable the ear to register acoustic sounds. To interweave tissue with electronics, the team used a 3D printer in combining a matrix of hydrogel, calf cells, and silver nanoparticles to form an antenna, with the calf cells later developing into cartilage. The researchers hope to further revolutionize this technology to one day produce internal organs and other biologically integrated sensors.
That wraps up this week's report. Be sure to join the conversation on Facebook, Twitter, and LinkedIn. I'm Melissa Barnes, and this has been your Engineering Update.